Sweet. Back to it with the stream. Yo. Moose, I was just about to start working. What's this? Give me that. Give me fuck. Go get it. There he is. Hello. Alright. I can play tug with you while I figure out what I'm supposed to do. Oh, no, that's the wrong thing. I moved to the side. Window. I want the code up. Okay, so I still have to figure out this shit with the McVitie Wilson stuff. For all residents, we're at the if is in bit. If not is in, then we have to do the evaluate function again. He's getting better at this. I need a better grip on it. So we're in the evaluate function. We said we'd do that first. Okay. If P has not reached its quota, then we do this. If P prefers R over least preferred match candidate, then we do this. We boot the program. Okay, match pro. The thing I'm worried about here is that what happens if, like, the matched resident that was previously matched, like, what happens to them? Does it say it's matched? Because I don't see them being, like, getting this removed from their program. R prime. Oh, we run offer again on R prime. Okie dokie. Yes, yes. What are you doing? Hey, what are you doing, you silly mutt?
Come on, Moose.
Oh.
Come on, Moose. Let Dad stream.
Okay, yeah, we run offer again on R plus. Well, R prime. So that's going to be what do I need? I need the ranking. Yeah, I need the ROL of the program. I need to see if the ROL of the program is in here. We already checked if there's is in, if that's true. So if not isn't, so we know that he's in the ROL. Now we need to know. Okay, so yeah. How do I check that? How do I check that? So the programs has an ROL, and it's basically the ROL is program rank order list. Gotta see here. Let's just open up Paint so I can think visually instead of in my own mind. So let's say I've got an array here. Boom. No, it's just boom. 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 I want you in my room. Let's spend the night together. Together in my room. Okay, so I'd need to know if the first index or the last index is the lowest. Okay, thank you, Steam. Is the lowest index, like lowest ranking. Ranking. Rank. That's it. In order of preference. Okay, so the last one is least interesting. So we need to know if R's ID appears before P dot what the fuck is its name? P dot matched, whichever at the top of the min heap, his ranking. So we need a reference to both of them. Okay, so we should, in this, as we go through the preferred, we should also figure out its ranking. And also figure out the ranking of Shooba-dooba. Our rank. Yeah, var our rank is an int. And then var least match rank int. And as we're going through, that means I'm going to need to take the int of that, find the index of it. So I'm going to do I is equal to 0, I is less than p dot roll, and that's going to do the length of that. Fuck you. And then I plus plus. And so instead of preferred, it's p dot roll I. It's true break. Okay, no, that the break was completely unnecessary the first time around. It's basically if you're going through and you find it, then it gets set to true. Otherwise, you're good. Okay, yeah, that's fine. So how does the int heap work for looking at the top? Because I just want to know the ID of the top without popping it. Do I have... Oh, I could check less. Less works? I don't know. Oh. How does the int heap work exactly here? Because what I'm... Oh, now I have to think. Okay, shit. Fuck me. Values int. Oh, no. Okay, Alright, length is just the length of our int array here. And we're doing it based on values, too. We're not even doing it based on, IDs. So I have no idea where the IDs of the people are going to be stored at the moment. So that's an issue. Oh, I have to rethink how the data type is being, like how the data structure is working here. Fuck. Oh, I don't want to think. Thinking hurts. Okay. Oh. So for the int heap, it's just an array of ints, essentially. We can get its length. We can see if one member of the int is less than another, which is important. We can swap their places, which is nice. We can push to the array. Well, yeah. Int heap. Oh, okay. Right. It's an int heap object. Okie dokie. Good. Yep. Is this the D reference? What is this? That's an int heap, yeah. Right, an int heap is just a thingy-mabob. Intriguing. So that should work because all we're working with here is an array implementation. Peachy cream works good for me. I could potentially adjust this that instead of an int, it is a struct that contains a resident and a ranking, and then just change this shit all accordingly. That could work. That could work potentially very well. Shooby-doo-bop-boo. Yeah. Yeah. Heap sort values. Heap init. Init. No, it's init. As in initialize. Push all values into the heat. Pop them out in sorted order. Where am I using the container heap stuff here? No, right there. Okay. Ouchies, my fucking back. Okay. This is different from the push from before. Yeah, that's my heap. And these are the different values of the heap. Okay. All right. So, could potentially go that route. Yeah, because that makes this difficult. Because I need to know its ranking. To know its ranking, I need to know its index in the ROL array. And then I need to fit it into the min heap somehow, where its value in the min heap is its ranking. So yeah, okay, we'll need to do that. So evaluate resident and program. So we have a resident and a program. If it's not in the ROL, then we make an offer. So we have is in, we check the whole ROL of the program. And if he's not in there, we run offer on that fella. So if it is in the ROL and he's not reached its quota, then no problem to it. Find next available program in ROL. That's going to be tricky. Unless we just run through all the ROL. Because he's not going to get matched in if he was previously matched in, bumped out. We'll just run that again, no problem. And then he'll just not get back in. Okay. Alright. If Pete prefers R over the last matched resident R. So we need to know R rank and least match rank. Least match rank. So that means we might need to get a peep or peak function to return a copy of the in heap instead of just popping it. We'll make a peak function for this. So func h int heap. I don't really need that. I can take a copy of it if I like. I'm not adjusting the values. It's read only. Yeah, peak any, and it's going to be return h0, or it's h at length. Yeah, because I'm pretty sure the top of it is stored at the end. Is that the way it's being done here? Yeah. If you push something in, it's pushed in at the end of it. And then when you pop, old is that. This is going to be an int heap, okay. Oh, so that is the dereference, okay. N is going to be length of old. X is going to be old n minus 1. Pop. Okay, yeah, so that is the last value. We are popping from the top, and this is the last value that it's adding. So that then begs the question. Where is the min being stored? Is it being stored at the top or the bottom of the heap? I don't know. Oh. I will put a comma here for the function. Probably doesn't work right. Yeah, warning, probably doesn't work right. Beauty! You see, this is how you code. You putting a fucking space there? You bitch. Alright, you bastard. Yeah, I don't know where the min is being stored here in the container. Package heap provides heap operations for any type that implements heap.interface. A heap is a tree with the property that each node is the minimum. Each node is the minimum valued node in its subtree. Okay. Minimum element in the tree is the root index 0. Okay. Okie dokie. Beauty. But we're popping from the end? Yeah. Yeah, from 0 to the last. Yeah, what this is saying is we have old being a reference to this int heap, which is just an array. And then what we're going to do is we're going to say n is equal to the length of old, which is, this is 1, 2, 3, 4, 5, 6. Yeah, it's going to be 6 elements. 6, and what it's asking is take x, which is going to be n minus 1, which is index 5, take it here and hold on to it, so x is equal to this fucker. And then we're going to adjust h to be a slice from 0 to n minus 1, which is 5. So we're only going to keep this part in h. But that's not the top. What? Is it using pop, the same sort of pop? It's using heap.pop. Okay. What? Yeah, pop removes and returns the minimum element according to less from the heap. The complexity is O log n, where n is equal to h dot length. Pop is equivalent to remove h0. Yeah, so even in this case of sorted, the minimum value should be at the top. What the fuck was the prof doing then when he gave me this? Qu'est-ce que la fuck? Qu'est-ce que la fuck? Like, bro, how do I show my YouTube chat here? Sorry, I'm getting squirreled. But it's a good question. Where the hell has it gone? Stop streaming, auto stop. I don't know. Studio mode. Studio mode? New. Settings. Stream. Can't change those settings right now. I'm in the middle of a stream, dummy. Alright, get back to what you're supposed to be doing. Paradigms. Concurrent programming in Go. Pipeline channels. Pipeline modules. Fan out. No. There we go. Some algorithms and data structures in Go. Generic queue. This is a heap. It's out of the implementation. And then this is heap sort. Huh. The heap is used completely differently in these two instances. Heap sort. No, it's supposed to be the same thing. Because this uses the container heap. Include. Yeah, the import function container heap, which is being used here with the heap.push and shit. So they're supposed to be working together. And this is where the FTM is used. Nums. Yet again, he does use them separately. He just could have gotten lazy. They're not supposed to be used together, but just here he puts them together. Yeah, because when we look at the main, it's just an int array with numbers. You then have the numbers, and then you sort it using heap sort. No, he uses an int heap for that, though. Okay, yeah, he uses an int heap in his initialization. Indeed. Why the fuck do I need to make this sort of shit to then implement heap? That seems silly. Why is Go like that? That's weird. Okay. So what's happening here? We've got all this functionality for heap. Then we have heap sort, where we pass in values. We then create an int heap. We initialize a heap using int heap. And then for all the values in this array, this integer array, we push it to, push needs a heap interface. Heap.interface? Okay. How do I know this is a fucking heap of ints? Yeah. I'm worried about that, Kate. Push all values into the heap. This is just a for range loop, essentially. I'm actually not sure what this is for. Could I get rid of that and have it work? I could. Why is it there? I don't know. At this point, I'm like thinking about asking ChatGPT some questions. What the fuck is this shit? Like, bro. Pop them out in a sorted order. Sorted is just make an int array, yeah. And then for the length of h, yet you append heap.pop h. Eh. Wild. I don't get it. Go heaps. Yeah, that's a good question. Hmm. Heaps are commonly used to partially sort a set. Every insertion deletion from the set is followed by a fix-up to restore either min heap or max heap integrity. For example, a max heap can be represented as a binary tree where every parent is greater than its child. It usually takes a number of swaps to fix up a tree to restore the max heap property after an insertion or deletion. Even though all the set's elements are not globally ordered, the biggest value is always at the top of the max heap. As a result, heaps have a variety of practical applications. Max heap. Heaps can be implemented as binary trees with nodes and pointers, but most programming languages provide default heap implementations for lists. I personally found the standard library heap confusing when I started Golang. This is what I used when coming to Python. Cool. For comparison, here's the equivalent Go encode adapting from the container heap docs, which I will probably want to read. For container heap type tuple struct. Tuple heap. This is all the shit he's already shown me, beauty. Okay, so this is indeed how it's supposed to be done. It's just that Go heaps are stupid, apparently, and unintuitive. So we've got there we go. Yeah, we've got our type tuple. Yeah. Then have length. We have less. We have swap. We have push. Yeah. We have pop. That's it. Oh, that's irritating. Yes, Presto? He probably wants to be fed at this point. Stream's been going for a solid half hour. I want peak though. I want a peak thingamabob. We have pop. Okay. It's all this shit. Jerf. Jerf is even recommended in this fucking article. Max Hoffman. Max Daltub. Huh. Delta. Oh, there it is. Yeah, okay. Interesting. I don't want to do this because I feel it may very well fuck up my code more than it will fix it, because that's just how shit goes when I'm coding. What the fuck was I even on about? I was on about how the hell does a go min heap actually work, and how I might implement a peak function so that I can very easily peak the top of the thingamabob, the minimum ranked object, so that it I can compare its rank with the rank of the new resident here. Okay. Our rank is equal to int dot max val. Is there a max val for the integer? Go int max val. Math.maxint, okay. Why maxint? Oh, so I need to include math. Of course, it's not include, it's import. Math. Dot max int. There we go. That's it. That's what I need to do. I have to find the least match. So I need to know how to peek a heap, because I don't want to pop it. I just want to peek. Okay. Minimum element in the tree is the root at index 0. Heap is a common way to implement a priority queue to build a priority queue with the negative priority as the ordering for the less method. So push adds them while pop removes the highest item. Priority item. Okay. It should return the minimum. Let's just play around with it a little bit. Let us quickly comment out the main method here. And we're going to just create a quick little in heap in the main. Func main. Boom shakalaka. I'm going to want FMT for this shit. So I guess we'll copy lots of this stuff. Just copy that in. Boom. Sweet. And I also want to do, before I pop everything, oh, you could just, yeah, you can just fucking, look at that. That is essentially the peak method right there. Boom. Boom. Okay. Yeah. Instead of that, I'm going to do h.peak. Boom. Should be the same shit. All right. Go run into, fuck you, in heap.go. Peak works, baby. Fucking A, right? Okay, now I need to rework most of this shit to take on, instead of an int heap, it's going to be a residence heap, and it's going to be a struct res rank, where it's going to take on a fucking rank int. No, just rank int. And a resident. I think I do want that. Because we're mostly working with residents, right? Map residents. Yeah, that should work. I don't know, man. I don't know if that's the right call, but we're going to go with it for now. So everywhere we have an int heap. Refactor. How the fuck to refactor? Rename symbol to int heap to resident heap. Heap. Is everything going to be an int? Yeah, I am going to have to fucking do that, aren't I? We'll do it one at a time. But for now, it's been about a good 45 minutes. My head needs a bit of a break. So we're going to end the stream here and come back to this later.